Hello and welcome to a new short video. In this video I'll prove some Laplacian transforms. So let's dive right in. The first problem is really quite easy. We know the definition of the Laplace transform. Most of us do, anyway. So the Laplace transform of e to the at becomes the integral from 0 to infinity of e to the minus st times the function e to the at dt. This is simply the integral from 0 to infinity of e to the negative s minus a times t dt. If you solve this, you get e to the negative s minus a times t over s minus a evaluated from 0 to infinity. When you plug infinity into e to the negative t, you simply get 0, and when you plug 0 into it, you simply get 1 over s minus a, provided that s minus a is greater than 0. That is, s is greater than a. For the second problem, you need to be familiarized with the gamma function. The problem isn't so hard, really. We know the Laplace transform is by definition equal to the integral from 0 to infinity of e to the negative st times the function t to the p dt. And if we let st equal to u, and note that in order for the integral to converge, we must have s greater than 0, then the integral becomes 1 over s p plus 1 times the integral from 0 to infinity of up e to the negative u du. And this is the gamma function, just with some exchange of the typical variables. So this is simply 1 over s to the p plus 1 times the gamma function of p plus 1. The restriction p is greater than minus 1 occurs because the integral defining the gamma function converges if and only if p is greater than negative 1. For the last problem, we need to know integration by parts. That's really all we need to know. And something about the gamma function, of course. So, as we saw, the gamma of p plus 1 equals the integral from 0 to infinity of x to the p e to the negative x dx. And by integration by parts, this is simply x to the p times negative e to the negative x evaluated from 0 to infinity minus the integral from 0 to infinity of p times x to the p minus 1 times negative e to the negative x dx. This simplifies to p times the integral from 0 to infinity of x to the p minus 1 e to the negative x dx. And this is simply p times the gamma function of p. And by definition this is equal to gamma of p plus 1. If p then equals n, gamma of p plus 1 becomes gamma of n plus 1, which equals gamma of n times n, which equals n times n minus 1 times gamma of n minus 1. This is equal to n times n minus 1 times n minus 2 times gamma of n minus 2, which is equal to n minus 1 dot 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 times gamma 1. But the gamma of 1 is by definition equal to the integral from 0 to infinity of e to the negative x dx, which when being evaluated from 0 to infinity is just 1. Thus the gamma of n plus 1 equals n factorial. And so from the last problem we get that Laplace transform of t to the n equals n factorial over s to the n plus 1. And we're done.